Chemical warfare in the trenches, the deadly legacy of World War I. As dusk fell on April 22, 1915, Canadian infantrymen stationed near the Belgian town of Ypres heard the familiar rumble of enemy gunfire. Little did they know, this was no ordinary bombardment on the Western Front. Moments later, they witnessed a strange sight, a yellow-green cloud slowly drifting across no man's land. What they were witnessing was the dawn of a new and horrifying chapter in warfare, the introduction of chemical weapons. The use of chemical warfare in World War I was a harbinger of the brutality and inhumanity that would come to define the conflict. Over the course of the war, various types of chemical agents were deployed on the battlefield, with chlorine, phosgene, and mustard gas being the most notorious. The introduction of these weapons marked a significant escalation in the horrors of trench warfare, as soldiers faced not only the constant threat of bullets and shells, but also the terrifying possibility of being gassed, a slow, agonizing death that left indelible scars on those who survived. The first large-scale use of chemical weapons occurred during the Second Battle of Ypres. On that fateful day, more than 5,000 cylinders buried in German trenches released 168 tons of chlorine gas onto the unsuspecting Allied forces. The results were devastating. The eerie cloud of gas, carried by the wind, rolled over the parapets and into the trenches, transforming passive curiosity into sheer terror. Soldiers felt an intense burning in their heads, their lungs filled with what felt like red-hot needles, and their throats seized as if by an invisible strangler. Many fell and died where they stood, victims of a weapon that heralded a new and terrifying era in warfare. To understand how and why chemical weapons made their debut on the battlefield, we must look at the broader context of the war in early 1915. By this time, the Western Front had descended into a bloody stalemate, with both sides entrenched along a 450-mile line of hastily constructed fortifications. The German plan to quickly knock France out of the war had failed, and now the Germans found themselves in the perilous position of fighting a war on two fronts. The heavily fortified Allied positions, reinforced with machine guns, artillery, and barbed wire, made any breakthrough nearly impossible. The German military needed a new weapon to break the deadlock. Enter Professor Fritz Haber, a German Jewish chemist whose contributions to science would prove to be both revolutionary and deeply controversial. Haber, who had already won a Nobel Prize for synthesizing fertilizer, a breakthrough that revolutionized agriculture, now turned his attention to weaponizing chemicals for use in warfare. Under his supervision, Germany began developing chemical weapons, with the goal of creating a noxious agent that could be released from cylinders, carried by the wind into enemy trenches, and incapacitate or kill the soldiers there. The idea was that troops equipped with respirators could then advance behind the gas and achieve a breakthrough. When the first chlorine gas was released at Ypres, it had a devastating effect. The French-Algerian 45th Division, which bore the brunt of the attack, was thrown into chaos. The soldiers, unprepared for the noxious cloud, fled their positions in terror, leaving a gaping hole in the Allied line. This was a pivotal moment, as it presented the Germans with a rare opportunity to break through the front. However, the Germans were initially so surprised by the success of the gas attack that they failed to exploit the opening fully. By the time they realized the potential for a breakthrough, Canadian and British troops had moved in to plug the gap, and the opportunity was lost. The success of the gas attack at Ypres left the Allies with a serious problem. Millions of soldiers were entrenched along the Western Front with no effective defense against this new threat. Something had to be done, and quickly. Contrary to popular belief, the Allies were not entirely unprepared for the possibility of chemical warfare. Most nations had already experimented with non-lethal gases, such as tear gas, and in the days leading up to the attack, Allied forces had captured German prisoners equipped with rudimentary respirators. Nonetheless, the scale and lethality of the chlorine gas attack at Ypres caught the Allies off guard. The response to this new threat was swift. Soldiers with backgrounds in chemistry quickly deduced that chlorine was the agent being used. Canadian Lieutenant Colonel George Naismith, for example, collected samples of the gas and immediately informed General Headquarters. His recommendation that soldiers use soaked bandages or strips of cloth as makeshift protection was adopted as an interim measure. Meanwhile, Field Marshal Sir John French, the commander of the British Expeditionary Force, urgently reported to the War Office that it was essential that our troops should be immediately provided with means of counteracting the effects of enemy gases. As a temporary solution, troops were issued handkerchiefs soaked in bicarbonate of soda to protect themselves from the gas. At the same time, efforts were underway to develop more effective countermeasures. A central laboratory was established at Saint-Omer, where chemists worked tirelessly to produce protective equipment en masse. Led by Colonel William Horrocks, a team of scientists and medical professionals produced 300,000 cotton-padded masks within the first week of the attack, and nearly 2 million within a month. These early masks, soaked in sodium bicarbonate, were designed to trap the gas molecules and prevent them from being inhaled. However, they were far from perfect, quickly becoming saturated and ineffective after prolonged use. As the war progressed, the development of protective gear continued to evolve. In London, Professor Herbert Baker at Imperial College developed the Black Veil mask, which used a photographic hypo solution to provide better protection against chlorine. In France, a similar innovation led to the creation of the smoke hood, which offered improved protection. These advancements were critical in mitigating the impact of chemical warfare, but they also highlighted a new and troubling aspect of this type of combat. Even when the gas did not kill, it drastically reduced the effectiveness of the troops, forced to wear cumbersome protective gear. The use of gas on the battlefield became a game of attrition, where the mere threat of a gas attack could force soldiers to don masks and hoods that made it difficult to see, breathe, and fight. Early gas masks often fogged up, had limited peripheral vision, and were hot and uncomfortable to wear. Communications were hampered, and the difficulty of performing basic tasks while wearing a mask reduced combat efficiency. In this way, gas warfare became less about inflicting mass casualties and more about weakening the enemy's ability to fight effectively. The British were quick to retaliate with their own gas attacks. In September 1915, during the Battle of Loos, the British unleashed chlorine gas against German positions. However, this attack was marred by controversy when the wind direction changed, causing the gas to blow back onto British troops. The incident resulted in several thousand casualties, though official records indicate that only 7 deaths were directly attributed to gas exposure. Nevertheless, the experience underscored the unpredictable and often uncontrollable nature of chemical warfare. By the time the British used chlorine at Loos, the Germans had already begun experimenting with a more toxic gas, phosgene. Unlike chlorine, phosgene was colorless and had a relatively benign smell, making it difficult to detect. It was also significantly more toxic, being 6 to 10 times more deadly than chlorine. When phosgene was first used in December 1915, during an attack near the Belgian town of Ypres, the British forces were fortunate that the newly developed P helmet provided some protection. Despite this, the attack still resulted in over 1,000 casualties, including 120 deaths. As the war continued, both sides developed increasingly sophisticated protective gear to counter the evolving chemical threat. The British Small Box Respirator, SBR, introduced in September 1916, represented a significant improvement in gas protection. This new mask featured a filter system that could be adapted to protect against various gases, making it far more resilient than earlier designs. The SBR was so effective that the Germans eventually abandoned large-scale cloud gas attacks in favor of delivering gas via artillery shells. Despite these advancements, chemical warfare continued to evolve, with each side seeking new ways to outmaneuver the other's defenses. One of the most horrifying developments was the introduction of mustard gas by the Germans in July 1917. Unlike chlorine or phosgene, mustard gas was not a true gas, but a vesicant, a blistering agent that caused severe chemical burns on contact with the skin. It was delivered via artillery shells, which dispersed the substance over a wide area. The effects of mustard gas were particularly insidious. It could remain active on the ground for weeks, making contaminated areas dangerous long after an attack had occurred. Mustard gas was especially effective as an area denial weapon, capable of incapacitating large numbers of soldiers and rendering entire sections of the battlefield uninhabitable. The British 1st Battalion, Hertfordshire Regiment, for example, was decimated by a mustard gas barrage in May 1918. Of the 513 men in the battalion, 511 were hospitalized due to exposure. While relatively few of these soldiers died, the psychological and physical impact of mustard gas was profound. Men who survived often suffered from temporary blindness, severe respiratory damage, and debilitating skin burns. The cumulative effect of chemical warfare during World War I was not just the direct casualties caused by the gas, but the pervasive fear it instilled in soldiers. The constant threat of gas attacks meant that troops were always on edge, knowing that even a slight breeze could carry a deadly cloud into their trenches. This fear was compounded by the knowledge that gas could strike anywhere, at any time, with little warning. General John Pershing, commander of the American Expeditionary Forces, captured the sentiment when he told the US Congress in 1919 that whether or not gas will be employed in future wars is a matter of conjecture, but the effect is so deadly to the unprepared that we can never afford to neglect the question. By the end of the war, the statistics on chemical warfare were staggering. Over 186,000 British and Empire soldiers were gassed during the conflict, representing nearly 10% of the 2 million British battle casualties treated on the Western Front. Of these, 6,062 died as a direct result of gas exposure. Mustard gas was responsible for the majority of injuries, causing nearly 125,000 casualties, though it accounted for relatively few deaths, around 2,300. Phosgene, on the other hand, was far more lethal, though its use was less widespread. Yet these numbers only tell part of the story. The true toll of chemical warfare extended far beyond the battlefield. Many soldiers who survived gas attacks suffered from long-term health issues, including chronic respiratory problems, skin conditions, and psychological trauma. Some died years or even decades later from complications related to their exposure. The legacy of chemical warfare in World War I was one of lingering suffering and a grim reminder of the inhumanity of modern warfare. In the end, chemical weapons did not achieve the decisive breakthrough that military strategists had hoped for. Instead, they became another tool in the brutal arsenal of trench warfare, contributing to the overall strategy of attrition that defined the conflict. While gas did not cause as many deaths as artillery or machine guns, its psychological impact and the sheer horror it inflicted on those who encountered it left an indelible mark on the war and the soldiers who fought in it. The use of chemical warfare in World War I also set a dangerous precedent for future conflicts. Although international treaties, such as the Geneva Protocol of 1925, sought to ban the use of chemical weapons, the threat of their deployment remained a constant concern throughout the 20th century. The lessons learned from the trenches of World War I continue to resonate today, reminding us of the devastating consequences of chemical warfare and the importance of preventing its use in any form. As we reflect on the horrors of chemical warfare in World War I, we are reminded of the resilience and bravery of the soldiers who faced this new and terrifying threat. Their experiences serve as a powerful testament to the enduring human spirit in the face of unimaginable adversity. And while the technology of warfare has evolved since those dark days in the trenches, the lessons learned from the use of chemical weapons remain as relevant as ever in our ongoing quest for peace and security in a world still haunted by the spectre of war.